Good morning, good afternoon, and good evening to you all from around the world tuning in to watch this. This is our first in a series of seminars organised by the UK's AI Standards Hub. And as part of our international collaboration with our dear colleagues from NIST, working on Trustworthy AI, the role of standards, which includes technical and socio-technical measurement standards, in promoting this whole global effort to promote the responsible use of AI. So in this seminar, my colleagues from NIST, Rover and Jesse, are going to introduce us to the AI risk management framework, which is a great piece of work that we first learned about almost a year ago now. And it's known as the AI RMF, which I'll default to every now and then. And they're going to present this to us, and over 300 of us actually tuning in right now from across the UK as well as the world. And we're going to start to explore in this first of our series of webinars how the RMF connects to standards. NIST, for those of you that don't know it, are the US National Institute of Standards and Technology, and they have a mission to promote US innovation and industrial competitiveness by advancing measurement science, standards and technology in ways that will enhance economic security and improve our quality of life. And just to put this into a bit of context, NPL is the UK equivalent of NIST, and we're part of an international community of around 100 entities around the world, of which the majority are owned by their nation states, but there are also some affiliates. And our role are to underpin and be the custodians of the international reference points, or the highest points of reference for international technical measurement standards. So the AI RMF was developed by NIST under a directive of the US Congress to assist organizations and companies to manage the risks of AI and promote the responsible use of AI. And the framework gives a practical guidance on the management of the AI risks. And the RMF core provides organizations with some suggested actions and outcomes. Now, it's important to note that the key principles of Trustworthy AI are shared across many proposals for different AI frameworks, although the terminology may vary. So better understanding how that terminology varies is actually one of the first areas of future collaboration between the Standards Hub and NIST. We're also looking to collaborate on other aspects over time, and especially in light of the recent announcements, things like the alignment of the RMF to AI standards, seeking to address ongoing international research problems, i.e. what are those metrics which allow us to at least understand how trustworthy an AI system might be. And a lot of this is motivated by the socio-technical nature of AI systems. So as I mentioned, this is the first in a series of 4 webinars we're doing. So do please make sure you've registered on the AI Standards Hub website for news on the upcoming sessions too. We will be taking questions, and we've got quite a healthy amount of time for Q&A after Rover and Jesse's presentation. So do please post questions in the chat. And of course, as is obligatory of these kind of things these days, we will also be requesting your feedback on this event through a short survey, and we'll put up the links and the QR codes for that in due course. Okay, so you're not really here to listen to me, but I will very quickly run through an overview of the hub, what we're trying to do, what our objectives and purposes are, and both our domestic and our international priorities. So thank you in advance for indulging me for a few moments before I hand over to the stars of today's show. So a quick overview of how we're going to run through. So I'll just do a few slides, a couple of minutes on the introduction to the AI Standards Hub, and then hand over to Jesse and Rover to explain and share with us the great work that they've done on the RMF. And then we'll have a Q&A session chaired by my colleague, Professor Mark Levine, who's a principal research scientist at NPL. So by way of a very quick introduction, all of this stems from the National AI Strategy, which was released a few years ago now. And our mission here is to essentially unlock the potential of standards to help with governance and enable innovation. We'd like to empower stakeholders to become actively involved in the international standardization journey by getting involved in developing standards, as well as being able to use them. Now, it's easy for me to say that, but actually the ability for people to engage with standards is quite challenging. And we tend to find that people need a lot of help with this, because it's not a world that everyone's involved in, nor does everyone appreciate how they can benefit from getting involved with standards. So in the UK, just over a year ago, we've just celebrated our first birthday. The UK government asked the 3 partners, the Alan Turing Institute, the British Standards Institution, and the National Physical Laboratory, to set up the AI Standards Hub to promote exactly the things that I've just covered. And we're working very extensively across various communities, supported by government. Now, there are lots of standards bodies out there. And it's well appreciated that international standards can be these tools to enable effective governance as well as innovation. And we've got similar examples in other sectors, other applications where this kind of work has been quite beneficial to global entities, especially in cybersecurity, in quality management, as well as telecoms and wireless communication. Of course, the AI journey is just starting for a lot of us. So there's a lot of opportunity here if we can get the right voices into the right room. Now, why do we want standardization for AI? Well, obviously, there's a lot of news, a lot of discussion about the opportunities, the threats. But actually, if we can set up these international standards that people are able to then interoperate with, they're able to adhere to, you can have all manners of benefits from things like the quality and the safety assurance of AI, making sure that it's ethically developed and used, and then also translating and disseminating and sharing knowledge and technology between different markets, different operators, different actors. Key, ultimately, is this interoperability. It could be that national standards don't always agree or aren't defined to be the same things, but as long as we can interoperate, then the world can work better together. And of course, if we're wanting to trade in these tools and technologies, we do need to make sure that we're complying to whichever jurisdiction we're trying to sell into or buy from. And there are other links to standards through to governance mechanisms. For example, when you want to certify these tools and technologies, as well as get them the official CE type marking. Now, standards are, of course, voluntary. They are developed by committees and not by standards bodies, and they're also developed by consensus. An example here is BSI alone, which is the British Standards Institute, handles around 3,000 different standards per year. And of course, one person's standards could be something completely different to others. So we do make a point of talking about the different types of standards. And the types of standards, for example, that NPL and NIST may be looking at are these pre-normative standards, which sometimes can take place for 3 to 30 years worth of development before we even get near the final international agreement on these standards. So I think the key point here is that these standards are national and international, and there's a lot of work that needs to be going into these things before we can have full confidence in them. So the UK's journey, not dissimilar to other countries and other jurisdictions, has been now going on for at least the last 2 or 3 years. And for us, it started off with the regulation white paper back in July 2021. And then through the course of that time, working up to a couple of weeks ago, where the UK held the first international AI safety summit, which will soon move over to Korea and then to France. And there were some interesting outputs from that AI safety summit, not least the mention and the development of some international collaborations to develop some safety kind of capability and the abilities to measure the trustworthiness and the confidence that you can have in AI. From our perspective, it was all about getting the non-traditional actors involved in AI standardization. So the AI Standards Hub has been proactively working across different types of stakeholder groups using the multi-stakeholder approach. So not just the large companies, but looking at academia, speaking to civil society, speaking to regulators, and all of the other groups that you can see here on the slides. AI will and is already affecting all of us, regardless of our profession or our personal lives and how we use these things. So it's really important to make sure that we get as many voices heard and inputting into the development of standards. And of course, AI itself is complex and the standards world is quite complex. So how can we help those that are interested, those that could benefit from it, and of course, ultimately our economies and our societies to benefit from standardization in AI moving forwards? So we identified several existing challenges. So the lack of the ability to access information easily and the relevant information that I might be looking for, as well as then the skills. And how would I take the importance of standards back to my organization, especially if that organization is a small startup and resources are quite limited? So what we decided to do in the UK is bring all of these communities together and hear what those challenges are, and then see if we could help address them by providing this central resource and platform. And that's part of the role that the Standards Hub partners take in all of this. I know a lot of people in the audience will be aware of the Standards Hub already, but for those that aren't, the Standards Hub consists of 4 main pillars, and it's not just an online platform. It's a combination of in-person and online activities and resources. And here are the key 4 elements. First of all is the observatory, where pretty much every AI standard that is either in development or has been development is listed on there. So you can very quickly and easily search by application or by topic of interest and find what's going on out there in the world, around the world. We then also have set up community and collaboration points, be that meeting in person or online forums. And then last 2 things, I just wanted to quickly share a couple of screenshots of some of the resources that people can go onto the Standards Hub to download. And so here's some examples of some of the knowledge and training resources that we've put on to the Standards Hub, and there are many others and many more to come. And then in addition, some research pieces, again, just a snapshot of a few of them. There are many more to come and many more already on the sites. Okay, so I said I wouldn't take too much time explaining the hub, and what I'd like to do now is actually welcome my colleagues Raver, Jesse, and Mark to switch on their cameras and unmute. And just by way of a quick introduction before I hand over to Raver and Jesse, is Raver joins us from NIST, as does Jesse. Raver is a research scientist in the ITL, which is the Infotech Lab at NIST, and she serves there as a principal investigator on bias in artificial intelligence for NIST's Trustworthy and Responsible AI program. Her research is focused on evaluating the risks and impacts of AI systems from the socio-technical lens, so extremely pertinent to some of the discussions that are going on right now. And her background includes a forensic science posting for almost 15 years at the US Secret Service, as well as a temporary duty assignment at the National Security Agency, as many other very high-profile roles. She has in the past also advised federal agencies and other groups about how experts interact with automation to make sense of information in high-stakes settings. Jesse is the latest addition to the team over at NIST, and Jesse's a computer scientist in the ITL, and he leads on the international engagements for NIST's Trustworthy and Responsible AI program. He has a bachelor's from MIT and a PhD from Carnegie Mellon, both in computer science. And his technical background includes research in NLP, natural language processing, at CMU, MIT, Google, as well as a small startup. And he's also trained hundreds of researchers in science communication and written many articles and video scripts for mass media outlets. Prior to his current role, he was a AAAS Science and Technology Policy Fellow at the US Department of State, where he led the department's international work on AI and human rights. And last and not least, Mark's going to chair the panel session after Raver and Jesse have shared their amazing work with us. Mark is a colleague of mine from MPL who joined in 2022 as the principal research scientist in data analytics and modeling. And that's part of our data science department where he leads our machine learning work. His research at MPL involves applying the machine learning to problems that involve trustworthy AI and quantifying uncertainties in key strategic applications and areas. Problems that you might see in autonomous vehicles or monitoring climate, other energy applications, and indeed a lot of work that we're doing in healthcare. He also is the technical lead from MPL's perspective on the AI Standards Hub. So I'll hand over to Raver and Jesse. Welcome both, and thank you so much in advance for the stuff that you're about to share with us. Just a reminder to everyone in the audience, do please post questions, and we will try and do our best to answer as many of them as we can when we get to the panel session. So Raver, Jesse, welcome, and over to you.
Thanks so much, Sunny. We have successfully transitioned the slides. Okay, excellent. Okay. So what we were hoping to do today was give an overview of what the AI RMF is and how it can be used within organizations to manage risks from AI. As Sunny said earlier, NIST, a piece of our mission is to cultivate trust in technology, and we have a long history of doing that through participating in standards development and measurement science. And to cultivate that trust in AI is no small challenge. I would say going back, oops, excuse me, looks like our slides are racing ahead here. I may actually suggest, Sunny, that you just advance slides on my behalf, since it seems it's a little unreliable. Can we slide back?
Yep, no problem. Let me just make sure that's working. Yep.
There we go. Thank you. Okay, one forward. Apologies, everyone. So especially going back to maybe around 2018, everyone, including policymakers, became much more aware of the variety of risks that can emerge from AI systems that might impinge on trust, that might make it more difficult to trust AI systems. There were problems like bias or malicious content, systems going off the rails in real world behavior in ways that they didn't perhaps during testing. And so if you can advance for me, Sunny, companies, governments, civil society, lots of different kinds of organizations started putting together frameworks of principles for AI governance. And in fact, there were so many of these that if we advance one more, the Berkman Klein Center at Harvard mapped 36 different sets of principles at one point. And many of these frameworks are wonderful. They're great. But even with all of this thinking and analysis, if you were a project manager or a developer, one more forward, please, it wasn't clear still what you should actually do to put all of these principles into practice. How do you actually make your systems safe, transparent, fair, all of these wonderful terms that appeared in so many of the frameworks? One more forward. This is where the AI RMF comes in. It gives a lot of very specific, concrete guidance on how do we actually operationalize these principles? How do we put the lofty ideas into practice? I should emphasize that this is voluntary guidance. It was not crafted as anything binding. So the point of showing you these tables here is not really just to is not to give you the details of all of these different components. We'll get into some of that in a few minutes, but just to emphasize that this really is one forward, please, a highly detailed framework that gives very concrete, actionable recommendations. At the same time, the framework also manages to remain flexible, despite giving enough detail to be put into practice. It remains flexible because it doesn't prescribe which of these practices, which of these targets are relevant or important for a given organization, given their applications, their institutional and societal setting and context, and their risk tolerances. It also offers a systematic approach, providing recommendations for actors across the whole AI lifecycle and all different parts of the organization, really trying to cover all the bases. It is also rights respecting. It's designed to encompass impacts on rights, human rights internationally or domestic rights, putting protection of individual rights at the forefront. Again, the whole idea here is we're trying to operationalize these principles that were in the broader frameworks, which effectively means operationalizing values in AI technology. So both the societal values that underlie legally protected rights, and also the values of the organizations that are designing and developing, deploying, using the technologies. The framework is also crafted to help determine whether and how well measures are being implemented. So aiming at that measurement science. And finally, perhaps most critically, as Sunny hinted at a few moments ago, we are trying to account for socio-technical contexts. These are not all engineering problems that we're trying to solve that generate risks. And even for the ones that are, there may be differences between how the social context affects what's acceptable. So the AI RMF is designed to help its users find the right practices, the right decisions that they can make, both as a function of the technical application that they're building and as a function of the human context where that application is going to be designed or used. That broad lens, that socio-technical focus is the secret sauce, or maybe the not so secret sauce for the AI RMF. AI systems are a product of these complex and interacting technical and human systems, and we need to account for all of that in risk management. That means it's not just about whether the technology works, but also that bigger context, which also means as a corollary that risk management means not just technical measures, but also fostering organizational culture of understanding and preventing negative risks, and also incorporating knowledge of that broader social context in addition to the technical knowledge that you need. All right, so that's a lot of promises about what the framework offers. Let's now delve into how the framework achieves all of that, and then we'll, after that, discuss some of the accompanying resources that help implement the framework and the past and future trajectory of the AI RMF. Let's start by establishing the scope. Of course, if we're going to try to talk about AI risk, we need to have some sense of what we mean by AI. This definition of AI system is based very closely on the OECD recommendation on AI. Give a moment for those who may not have seen it, just to read it. And this is not a super precise definition, which is fine. There is still consensus via the OECD that this definition is fuzzy in roughly the same way as the whole concept of AI is fuzzy. In other words, this more or less matches our intuitions for what kinds of systems we ought to be concerned about raising particular issues from an AI perspective. The second term that, of course, we need to be very conscious of is risk. That term tends to have negative connotations. When NIST uses that term, we mean it to encompass, in general, the probability of an outcome and the magnitude or degree of an outcome, which may be positive or negative. So we're really thinking about the entire risk calculus here, including the beneficial impacts that a system can have and how big and likely those benefits are, as well as the potential negative outcomes that you may need to manage, and you may need to trade those off against each other. This is, again, based on the consensus definition. So as we move into discussing how the AI RMF addresses risks from AI systems, let's talk about a couple of key challenges that the framework has to address. First, measuring risk is difficult. Risk may be very different. Things that appear in practice may be very different from what you see in the real world. It can be unclear what risks to assess or care about. There can be interactions between the evaluations of risk that you have from different stages in the life cycle. So the AI RMF tries to recommend actions you can take continuously throughout the life cycle from a variety of perspectives that collectively help reveal and quantify these risks. A second challenge is that risk tolerances vary. What I mean by risk tolerance here is just an organization's readiness to bear a given risk given its objectives. NIST does not prescribe risk tolerances or any buckets of risk. We don't say this is high risk, this is low risk, because that's very contextual. And so what we instead do is we say there may be laws or regulations, professional norms, that sort of thing that may dictate what your risk tolerance is, what your levels, thresholds should be. If those do exist, you should use them. If those don't exist, you should establish your own risk tolerances and thresholds consistent with your own values within your organization. And then either way, given the established risk tolerances, move on to apply the guidance from the framework given those tolerances. A third challenge is that risks have to be prioritized. We can't necessarily eliminate all risk. And so part of the purpose then of the AI RMF is to help offer guidance on how to prioritize risks, given that you can't necessarily get rid of them all. Finally, risk management has to be integrated across an organization. Different actors have different levels of responsibility, different amounts of visibility, depending on where they sit in the life cycle, what their roles are. And yet somehow they have to come together to achieve adequate risk management within the risk tolerance. That also means risks beyond AI have to be managed, and that management has to be incorporated as well. Cybersecurity, for example, is another set of risks that also the management has to be integrated between those two. So the RMF, the AI RMF, suggests processes and practices that can be followed across the organization to help ensure this coherence. Again, notice that a lot of these are socio-technical, at least as much about human systems and human practices as about the technicalities of the systems. So what that means in practice then is that the AI RMF is really trying to promote two synergistic sets of outcomes. And now we'll really get into the meat of the framework. First, we have to address the technical characteristics of the system itself that makes a system trustworthy. But second, we also need to address the practices of all of the humans and the organizations surrounding a system that determine how its impact manifests in the real world. In other words, kind of mantra for the AI RMF is that we're going for AI system trustworthiness within a culture of responsible AI practice and use. So let's address each of those in turn. Starting with the system trustworthiness side, views might differ about what exactly makes a system trustworthy. It's, of course, not something you could define with perfect rigor, but there are some key characteristics that are widely agreed upon as important for trustworthy systems. The AI RMF lists 7 of these: valid and reliable, safe, secure and resilient, explainable and interpretable, privacy enhanced, fair with harmful bias managed, and accountable and transparent. And the framework goes into much more detail on each of these characteristics and how they relate to each other, perhaps including what kinds of trade-offs you might need to make between different characteristics, as well as what it means to say this is sufficiently private, this is sufficiently safe, etc. Thinking then beyond the technical systems, a key counterpart to that, as we've discussed, is the culture of responsible use and practice surrounding the system. And that has to pervade the activities taken by all the AI actors across the entire life cycle. Again, this is that socio-technical nature. Each of these parts of the life cycle comes with its own actors and activities, and different teams are working under different contexts at those different stages. You might have, for example, different risk perspectives from different stages. Developers of a pre-trained model, might have different perspectives from someone who's then deploying that same model in a particular use context. So the risks that come to mind for them might be different. And then, of course, we might reuse, repurpose, misuse technology in ways that the creators did not imagine. So again, this is all about creating risk culture, risk management culture. Notice also that, sorry, back one, Sunny, all of these stages of the life cycle really are iterative. We're not just collecting the data once and then being, deploying the system and being done with it. We have to do each of these repeatedly. And that also means that risk management has to be iterative as well. You're not done after having followed the practices once. Now to get into the key elements of the framework that have to be applied across all of those stages, I'm going to turn it over to my colleague, Riva.
Awesome. Thank you, Jesse. All right, getting situated here. Okay, so the framework has a core, which we call it a core, which organizes these risk management activities into something we call functions. There are 4 of them. And these functions really help organizations move from these high-level principles that Jesse spoke about to the specific practices. Each of these functions are then broken down into something we call categories and subcategories. There's actually 19 categories and overall 72 subcategories. So what the terminology is not necessarily what everybody needs to focus on. It's more about the fact that we now have 72 actionable events, activities that organizations can carry out to move from principles to practice. And of course, as we've been saying, all of these practices are iterative and can be applied in any order, but they do tend to typically follow a starting with govern and then moving to map, measure, and then manage, and then repeat. So function activities are designed to be implemented in a way that reflects diverse and multidisciplinary perspectives, including views of actors that are external to the organization, such as subject matter experts in the underlying context that the technology is deployed in, as well as potentially impacted groups. So just a few words here about each of the functions. The govern function is where organizations set up policies, procedures, and institutional structures to align operations with the societal values, also organizational values, and existing legal and regulatory requirements. This, again, is less about the technology itself and more about fostering an internal risk-aware culture that can incorporate a broad set of perspectives. As AI system risks and trends advance, organizational governance does help to liberate organizations from playing catch-up and enables the public to build up trust. The map function is where organizations establish the context to frame the risks that are related to the AI system of focus, along with making sure that they have the necessary internal expertise within the organization to identify and evaluate these contextual factors while integrating external voices into the process as is practical. The map function sets the foundation for AI actors to anticipate risks of the use of AI systems beyond the original expectations and to consider impacts beyond just the model and from a real-world perspective. This is the socio-technical special sauce that we talk about often. The measure function is where we set up objective, repeatable, and scalable test, evaluation, verification, and validation processes. We sometimes shorthand that to TEV, for tracking metrics for the trustworthy characteristics, as well as for social impact and human AI configurations. And then in manage, this is where organizations can prevent risks that have been mapped and measured, and then respond to them if they materialize in line with policies established in the govern function. Responding here may entail treating the risk, recovering from it, or preventing further damage, as well as continuous monitoring and communicating about AI system failures and impacts. So next, we're going to move into how we implement the AI RMF. And so first off, we have a wealth of information about the framework on NIST's website. And then to support and operationalize the framework and its accompanying playbook, we launched in March a Trustworthy and Responsible AI Resource Center that can be seen at airc.nist.gov. The Resource Center is a one-stop shop for foundational content, technical documents, and AI toolkits. It also has a glossary and links to measurement methods, metrics, data sets, and crosswalks. We try to provide examples of AI actors outside of NIST who are using the tools and give them the opportunity to share knowledge and experiences. There's always more to come on the AIRC. We update it regularly, just kind of generally, and organizational experiences specifically. One resource I want to zoom in on is on the next slide, and that's the AIRMF playbook. It's an online resource containing hundreds of suggestions that go into more depth on actions you might take to implement each of the subcategories, those 72 subcategories that we were talking about. And just like the framework, it's also not a checklist. Organizations are encouraged to identify the outcomes that are relevant for their own use cases, and then go to the playbook, identify and adopt as many suggestions as makes sense for achieving those in a manner that fits the specific context and their organizational skill sets. So the framework is kind of evergreen. It won't be updated for at least 3 to 5 years, but the playbook is intended to be updated approximately twice per year based on feedback from people like you all and anybody else who wants to send us feedback. So it's also in many ways a venue for the community to build out suggested practices and learn from each other. Next slide. So especially with all these resources, the framework is ready to implement off the shelf in a variety of ways. So you don't have to wait to do anything to get using it. The most straightforward way is to create an application to specific systems within specific organizations. We call write-ups of these applications use cases. And the narrowest example here is application to one system. As you can see, like a bank would create a use case for how facial recognition might be used in customer onboarding. And then slightly broader is to apply the AIRMF to an entire organization across all of its systems. And what it means to apply the AIRMF for a use case is to sit down with the tables of actions from the framework and the playbook, pick the ones that make sense, and then execute on them, or at least figure out how to move to the next step. And then we can also think about applying the framework at a much broader scale to an entire sector, such as criminal justice or lending or hiring. We call these profiles, and that looks more like specialized guidance for that sector, a filtered and augmented version of the framework and the playbook, where we translate items from the functions tables of subcategories and to how they apply for that sector. You would select, just like you would for a use case, you'd select items from the playbook that apply to that sector, and then add considerations or recommended actions that are unique to that sector. We can create profiles not just for sectors, but also for cross-sectoral technologies like large language models. Again, how do we apply this technique to large language models, or what actions might be uniquely helpful for them to execute the 4 functions? And then similarly for cross-sectoral organizational processes like procurement or use of the cloud. Profiles can also have a temporal dimension. We might have a profile for what an AI in lending looks like now, and then another for its target state, what we're trying to build towards. Organizations can build these use cases or profiles for their own situations, whatever seems most helpful for the scope of AI applications they're trying to address. And the terminology here isn't the important thing, whether it's a profile or a use case. The big takeaway here is that using the framework can be as complex as a multi-month consultation process within and across a given industry and working with stakeholders in that industry, but also as simple as sitting down with a spreadsheet, looking at the subcategories and the playbook actions across all the 4 functions for a couple of hours. Next. And finally, how and why did NIST do this, and where are we going next? Next slide. So NIST was mandated by Congress in January 2021 to deliver a risk-based framework for managing the risks of AI. And then for 18 months, starting in July 2021, we worked with industry, civil society, academia, and public sector stakeholders in an open and transparent manner with 3 workshops and 3 opportunities for public comments. All of this information is available on our website if you would like to dive in. And in the end, we heard from over 240 organizations from across those stakeholder types. The key here was that being very open to where the input would take us and try to synthesize as much of it as possible into the product. The net result is a framework that has near universal buy-in. Industry is on board, civil society is on board, Congress talks about it, they're very proud of this framework that they mandated, and other governments are using it as a basis for their own governance frameworks. So we really hope others can build on all of this work alongside us. There's much more work to do, but so much consultation and synthesis has already been done, and we see a lot of value here for the global AI governance community to mine. Next slide. And we ourselves are building on this already. We released an AI RMF roadmap at the same time as the framework, and work described in the roadmap is intended to help fill gaps in knowledge, practice, or guidance, and be useful to a broader audience in pursuit of trustworthy and responsible AI. We've already started work in the top 3 areas that NIST considers top priorities. So going in order, alignment with international standards. NIST's role as federal AI standards coordinator means that we work across the government and with industry stakeholders to identify critical standards development activities, strategies, and gaps. Based on priorities outlined in a NIST-developed plan for federal engagement in AI standards and related tools, we track AI standards development opportunities, including ones where the framework could play a helpful role. We also make recommendations to the US government's interagency process to optimize engagement in standards development. And NIST also participates directly in selected AI standards activities. For the expanded TEV efforts, NIST is working with the broader community to develop tools, benchmarks, test beds, and standardized methodologies for evaluating risks in AI and system trustworthiness, including from a socio-technical lens. Some exciting new stuff here is coming from the recently announced presidential executive order on AI and our AI Safety Institute, and also an upcoming evaluation. And then AI RMF profiles, as you just heard, other areas might take a little longer, particularly given the EO, but we are interested in continuing to work on these profiles and welcome collaboration and input on them. You can find use cases, we do not have a finalized profile just yet, but you can look at, find use cases on our AIRC website. And finally, I think we are done. NIST, of course, welcomes questions and suggestions at any time, and we know that the community's involvement will be vital in advancing trustworthy AI and risk management. Thank you. Ready for questions.
Mariva, Jesse, thank you so much for taking us through that. I'll hand over to Mark to chair the panel and Q&A.
Thank you very much, Riva and Jesse, for an excellent introduction to the NIST AI framework, risk management framework. And we do believe that the RMF is critically important to the endeavor of AI safety, which is central to the success of AI, as we have seen from the recent summit in London and the executive order in the United States and other governments likewise. And we think this is central to the success of AI, which is prevalent in many fields, and obviously we're all exposed to it through the internet. What I would like to do is there are quite a few questions on the Q&A, and we won't probably have time for all of them, but I'll try and get through as many as we can. And please try and be concise in your answers, unless you really have to give a really long answer to it. Okay, the first one, which I think is really interesting, and actually I'm quite curious because you didn't mention that. And the question is whether the RMF extends to generative AI.
Absolutely. The way we define AI in that slide, as you can see, and we could go back to it, but the way we define it in the slide in the framework is that it applies to recommendations and generated content. We got that question a lot when we first, because we released the framework right in the beginning of the ChatGPT excitement. And a lot of people thought that everything we had built could be thrown away, but of course, no, it's absolutely in scope. And we, in fact, we have a generative AI public working group here at NIST that we stood up in June. And we are just about done with developing a profile, a cross-sectoral profile for generative AI with the AI RMF. Thank you.
Yeah, thanks for that. I guess just to mention the Trustworthy AI, which is one of the pillars of the RMF and other frameworks, includes generative AI in it. There's an interesting question here, which I guess I can split into two, but the first is you've got other frameworks. You've got a risk management framework in this and others. There's some safety frameworks. How does this overlap with those prior frameworks? I guess sort of complementary to that, does it fit into those?
I can answer that real quick. The NIST framework is not underneath it. These are all separate and distinct frameworks. And however, they are meant to be used together within your enterprise risk management approaches. And they were designed to be cross-cutting and work together. It is again separate from the CSF and 800-171 and separate from the RMF, but they take into consideration all of the guidance from those. And we say, we have a number of appendices in our AI RMF. And in one, we specifically talk about the differences between managing the risks of AI versus other software systems. And in that, we talk about when organizations should consider using those other frameworks.
Okay. I've got a question sort of my own here to complement the previous question. It's really about the question is how will differences in the rules of governance between different countries, for instance, how would that affect the way the RMF is used? Because I assume that you've designed it, well, it's obviously US-centric, but you may have already thought about the international market here.
So one of our intentions for the AI RMF is for it to serve as a basis for international standards as well. Obviously, it was originally created for a domestic purpose, but we do believe that it can be, again, very informative for the broader international AI governance community. And so we're working closely with standards organizations, and we're starting to really ramp up international work on bringing the AI RMF to broader international audiences and making sure that it can serve as a resource for others, and making ourselves available as well to help that happen.
Brilliant. I hope that many do from different countries, many do call you up on that one. All right, so what I would like to ask you now is about the executive order. And the question is, if I can find it, I can't find it, but I remember it. It's how's the RMF going to be? What sort of work are you going to be doing on the RMF post the executive order, which came out, I believe, last week?
I can answer that. So the framework is at the core of the the way we are approaching the work in the executive order. In many cases, the framework is central to deliverables in the executive order. They reference a profile for the AI RMF for generative AI. And the test and evaluation piece that, you know, kind of that we knew we had to build to extend the measurement function in the AI RMF that we were already working on is now also part of the executive order. But there are things in the executive order that are you know, separate and distinct from the framework. For example, the synthetic content items. We don't explicitly go into that in detail in the framework or actually in the playbook, but now we will be able to build out guidance on that.
Thank you. Here's another question, which hopefully is quite easy to answer, but I think it needs to be said explicitly because it's very important in the context of the socio-technical framework. And the question is that this particular attendee, he didn't see a reference to usability in the technical criteria. And the question is this covered in the framework?
Yeah, so I mean, we actually go beyond usability. I think it's taking into consideration how humans make sense of information, take up information, regardless of interface. And in fact, there's an entire appendix on all the different factors and how we kind of think about human interaction, whether it's human AI teaming, human in the loop, all of these different roles and responsibilities. And we do have a couple of subcategories specifically focused on human AI configurations and the need and what needs to be taken into consideration, what needs to be addressed there. The specific details are in the playbook. So we do have those. I believe they are in map and measure. So yeah, thank you.
Thank you for your answer. This is an interesting question, again, to do, I guess, with the socio-technical. And it's the question of when you're mapping risks. Did you give any thought to how to map the legal risk? Because, I mean, the question goes on and says in the beginning that it's beginning to be apparent that in building AI and machine learning models, that the licensing of them by corporates can attract significant copyright, patent, data privacy, data protection, and so on.
Yeah, these are absolutely included under the kinds of risks that we would encourage organizations to map as part of that map function. In fact, there are explicit callouts to legal concerns that may arise. I think it's important to recall that this, and Riva may want to weigh in with more detail here, but the entire approach of the AI RMF is to give a kind of very broad suite of ideas and recommendations that can then be drawn on and selected by the organization. So not every organization or not every AI system is going to have to raise particular legal concerns, but it is certainly among, it's on the list of types of risks that an organization should consider in the mapping process. And we offer some concrete suggestions about what kinds of analysis might be necessary to identify and understand those risks.
Yeah, and I would just add to, like, in govern and map, we talk, there are subcategories that specifically talk about the need that you are, the outcomes should be that you've taken those into consideration. And then also in the playbook, we talk about maintaining awareness of legal and regulatory requirements. So that has to be built into your governance practices and across the entire life cycle.
Thank you. I have a question of my own here, which I think is relevant to the conversation. And it's to do with how does an organization assess their measurement capability in such a fluid and changing field? Because AI isn't sort of sitting still. It's very dynamic, and things which are, even terminology is changing. So there's a lot of change happening. So how can we be sure that our measurement capability is the correct one or sufficient to cover the risks?
Well, I will just say that there is an actual subcategory directly on that. I think it's measure 2.13, actually. That is specifically about, like, okay, now that you've selected all these measurement approaches, go back and validate whether these measurement approaches were useful and actually the right thing. So that gets a little bit to that whole iterative piece of using test and evaluation across the board. But considering what are the best practices, it's almost like it's at this like super high level. That is exactly what we will, well, not the only thing, but very much a lot of what we will be doing under the EO. Especially in this fluid environment. What we have right now are a lot of testing protocols that are likely not adequate for the current, the current state we're in. I think that would be probably an understatement. And so that is this building up a new measurement science for trustworthy AI is the goal of the NIST NIST-led US AI Safety Institute. So all of that will be the forthcoming work. But in the meantime, there are activities that are in the playbook and framework to address that.
Okay, thank you. This is an interesting question. It's to do with the OECD definition of AI, which the attendee says it adds the adjective explicit and implicit objectives. This isn't yours. Do you know why?
I can speak a little bit to that. First of all, just keep in mind that the NIST framework was released before the OECD update referenced here happened within the last month, approximately. So, perhaps this would be reflected in a future version of the framework. I don't know, but it's, the very simple answer is because ours was based on the previous version of the OECD definition. As far as why the OECD ended up adding those terms, the reasoning was that so at a purely technical level, there are always objectives specified to a system in some fashion by the system's creators. However, the objectives specified by the humans might not be what the humans really actually cared about at an underlying level. So we might say you need to the system should be targeting minimum deviation from human what it sees humans doing in this task. Well, maybe that's what we want, but maybe what we actually care about is you adhere to the laws or something like that. So the underlying kind of more abstract human objectives may be more implicit in the system, and that was the kind of thinking that drove that addition in the new definition to recognize that there may be that distinction.
Can you elaborate on how this sort of relates to the concept of alignment? Because that's sort of a much discussed sort of term. Is that what you're getting at when you say that it's the humans and the AI may have a different sort of way of thinking about solving the problem, so to speak?
I think that depends who you ask. There were certainly people who were involved in the update to the definition who were thinking of it in those terms. I don't think you have to think of it in those terms to find the distinction relevant. The word alignment means different things to different people also on its own. So it means it's a little bit of a minefield perhaps, but at a very broad level, I think there's no question that this is true even for traditional software. What you tell the system to do is not always what you actually want it to do, and so that's kind of the distinction that those terms in the new definition we're drawing attention to. Within NIST, I think we also had some skepticism about the necessity of adding those terms, only because explicit and implicit is the entire universe of possible options. So of course it's going to be either explicit or implicit. But that broadly, I think that's the that notion of mismatch is a potentially useful thing to think about, whether or not you want to think about it as alignment or as the particular mismatch problems that the word alignment is often used to describe.
Thank you. Just a second. This is an interesting question, which I guess many would like an answer to. And if you could answer it briefly, because I'm sure you could answer this in very much detail. So if you could give the main points on how the NIST RMS framework differs from other risk management frameworks for AI, and there are a few of them around. I won't mention names at the moment. I think Sunny mentioned some in his slides.
So one of the key ways that the AI RMF is different is the element that I highlighted at the very beginning of the presentation, that we are not looking to prescribe levels of risk, thresholds, risk tolerances. We're offering a much more flexible framework than I think most of the other frameworks would allow for. So we're basically saying, here is a wide menu of measures and targets that you can choose from as needed for the context that you're working in, which may include regulatory context as well, should include regulatory context as well. But we, as within the context of the framework, are not being prescriptive about what is acceptable risk. We are saying, given that you have some concerns or values about what risks may be acceptable, what levels of risk are acceptable, here are some measures you can take procedurally, process-wise, to try to manage risks to keep them under the target risk level. And I think that's really a unique feature of the framework.
Okay, thank you. By the way, Sunny, please stop me when we reach the time. I'm just going to try and plow through as many as I can. I guess another question, which is, I think, a very interesting one, is to do with certification. And I guess what they're asking here is, are you planning for independent certification? But what I would ask more generally is, how do you think certification would fit into the framework? So could a third-party certifier use the framework in some way to do certification? Because that's going to be quite critical, I think, in the future, especially with companies that don't have the time to sort of go through all the details that these frameworks, such as NIST RMF, which is quite detailed, which is good, allows for.
Yeah, I mean, I would just say, so because it's voluntary, it's not something organizations comply with, but there are, I think, already companies who offer, training in the AI RMF, I think, or so we hear, and then potential certifications, but that is not in NIST's purview. That would be third-party efforts to develop that material and those certification requirements and criteria.
Yeah, I think the companies generally feel, that's the impression, is that if they have some sort of certification to such frameworks, that will imply that they're compliant to any other government rules. But as you say, that's not necessarily the case.
Yes, much more complex than that. And I think the executive order it puts us in a different space on that, but yes.
One question that I have, I'm not sure this will be the last question, but we'll see, is I've noticed that there's going to be an AI Safety Institute, which I believe NIST has a very big there's a very big stake for NIST in this. And how does the work on the RMF fit into the sort of remit of this new AI Safety Institute?
Yeah, so the Safety Institute is NIST led. We will run it out of NIST. In fact, there is a workshop this Friday, and we will get the link. People want to attend virtually and live stream, watch the live stream. The framework is kind of the overarching theme of the Institute. I mean, so it's kind of, it's not all about the framework, it's bigger than that, but it takes the perspectives that are and themes and concepts such as socio-technical approaches and testing and evaluation and broad set of non-prescriptive approaches into account, and then a lot of the evaluations that will happen under the AI Institute are to provide the add-on details and fill in the gaps in measurement that we currently have for organizations trying to implement the framework fully.
Thank you. Is there room for one more question, Sunny?
I'm afraid not, Mark. It's 1 minute before 1/2 past, and I think we've kept our,
Okay.
our good colleagues online for as much as long as we could, and also I'm sure others have meetings. But first of all, I'm sorry, it feels a bit rude to cut the conversation dead. I'm sure there's so much more we could do. I've seen the word useful come up a few times, and that was part of my script as this bit. So I really do hope this has been useful for everyone that's dialed in to watch this. I've learned a lot just by spending this half an hour, 60 minutes with everyone. Clearly, there's a lot of stuff happening in this area, and this conversation is really just starting. So please do join us and have your voices heard. In the future webinars, we're going to start looking at things like the crossover between the RMF and standards activities, might do a deeper dive into what you really need to be thinking about if you're trying to do some measurement for AI safety. I would remind everyone, if you do have a few minutes spare, it won't take too long to fill out the survey link that we've got on the screen there, just to get your feedback and make sure that we can make these even better. Not that today wasn't great, it's phenomenal. But so with that, I'd like to thank especially our contributors, Raver, Jesse, Mark, thank you so much for taking the time to speak with us today. The AI Standards Hub team in the background actually works quite tirelessly making this happen. So cheers to you guys as well. And of course, everybody, wherever you are in the world, for taking the time to join us on this first webinar, and really hope to see you and engage with you through the Hub on future discussions. Thank you all so much.
Thank you.